Hi, I'm Ben and welcome back to my channel. In this video, I'm going to explain exactly how to use the text widget in TouchGFX. We are going to explore the functionality of the text widget in TouchGFX, including how to handle typography and dynamic resources. First, drag a text widget on your screen. Over on the right hand side, you will see the widget's name. It is usually defaults to something like text area 1. You can rename this here or to whatever you want. Next is positioning. You can adjust the location by typing the coordination of it or simply by dragging the widget itself. As you can see, it snaps to different places on the screen, so you can easily align it. Then we have the lock option. If you check this, you won't be able to select the widget on the canvas anymore. To select it again, you will need to find it on the screen list and unlock it from here like this. Then we have auto size. When it is enabled, the widget will automatically expand or shrink to fit the text you type here. Finally, there is the visible check, which simply lets you to toggle the widgets on or off. Next, we have the text ID. Whenever you place a widget, this ID is auto-generated. Next to it, there is an icon that lets you assign this text to a specific group in your text database. I will explain exactly how to organize these groups later in this video. Below that, we have translation. This is where you define what actually appears on the screen. I will change this to say hello world for our example. Then we will have the wildcard option. I will explain wildcards in just a minute. Then we have typography. This controls the font size of your text. I will also show you how to customize this value shortly. Next is the alignment. You can set your text to align to the left, center, right within the box. Then we have the white text action. This controls what happens if your text is too long to fit inside the box. By default, it is set to none. I will explain this part also with an example later in this video. Moving on to the appearance section. First, we have the color picker, where you can easily change the color of your text. Below that is the alpha. This controls the transparency of your widget. 255 is fully visible and lowering it makes the text more transparent. Next is the line spacing, which lets you adjust the vertical space between lines of text if you are using multiple lines. You also have the text rotation, where you can type in an angle like 90 degrees to rotate your text. Finally, let's look at the interaction option at the bottom. We have draggable option. If you check this, user can actually drag the text widget around the screen by touching it. Then we have click listener. Enabling this allows the widget to detect touches. You can then assign a specific function or interaction to trigger whenever the user clicks on the text. Then we have fade and move animator. These are advanced animation mix-ins that let you create a smooth transitions. So far we have only used fixed text, but what if we want to change the text value dynamically? To demonstrate this, I will drag another text widget onto the screen. In the properties panel, I'll change the translation to my number. Now we need to add a wildcard. You can do this by clicking the add wildcard button here. Once the wildcard is added, we need to configure it. For the initial value, I will set it to 012. Make sure to check the wildcard buffer. I will set this to 10, this reserve memory for our text, which is enough to hold a standard integer. If we don't set a buffer, the program won't allocate memory to change the text later, and the application may crash. Now we need a way to update the value in the code. You could use the MVP pattern I explained in previous video, but I will use the interaction tab right here in the designer. Click the plus sign to create a new interaction and set a trigger to every tick. Since the screen runs at 60 frames per second, it means 60 ticks, I will set this to 30. This means our function will run every 30 ticks or every half second. I will select the action to call a new virtual function and I will change the name of it to function text. Finally, click generate code to create the project files. Now let's look at the code TouchGFX created for us. Open your project files and navigate to screen1.cpp. You can quickly open the matching header file screen1view.hpp by holding Ctrl and clicking on the file name. If you look inside the base class, you will see two virtual functions: handle tick event. This is a built-in function called every single tick, and function text. This is a custom function we just created in our interaction tab. We need to override this custom function. So copy the declaration from the base class and paste it in your screen1view.hpp file. Now let's write the logic. But how do we format the text? Go back to the TouchGFX Designer. Next to the widget name, click the help icon. This takes you directly to the documentation. Scroll down to the function section. You will see for simple string we use Unicode string copy. But since we want to display numbers, we need to use the Unicode smprintf. Copy the example code and paste it in your function. Now let's clean it up. I only want to show numbers, so I'll delete the second variable from the example. I will define a variable to count, then I will increase it by 1. Update the function to use your specific widget buffer. Since I named my widget text area 2, TouchGFX automatically generate a buffer called text area 2 buffer. Finally, and this is the most important step, you must call the invalidate function. This tells the graphic engine that the widget has changed and needs to be redrawn. If you forget this, the numbers on the screen will never change. Now compile the code and let's run it in simulation. When we run the simulation, you will notice something strange. We see the numbers 0, 1, and 2, but as soon as the counter goes higher, we get a question mark. Why does this happen? TouchGFX is highly optimized to save memory. It only loads the font characters that you explicitly use in the designer. Since we only typed 0, 1, 2 in our initial value, TouchGFX only generated the graphics for 0, 1, and 2. It has no idea that we want to use 3, 4, 5 or other letters on it. To fix this, we need to tell the compiler to generate the graphics for all the numbers. Go to the text tab on the far left and select the typographics section. Here you can see the font settings. You will notice a column called Fallback characters. This is set to question mark by default, which explains why we saw the question mark earlier. It is the placeholder for any missing characters. To add numbers, we have two options here: wildcard characters and wildcard range. Use wildcard character when you need a specific individual symbol. For example, if you need a dot, comma, or a percentage sign, you would type them here. TouchGFX will generate the graphics for just these specific symbols. Use wildcard range when you need a sequence of characters, like numbers or the alphabet. To include all the numbers, type 0 to 9. To include all the letters, type A to Z. For our counter, we simply need to type 0 to 9. This tells TouchGFX to generate the font graphics for every number from 0 to 9. So our counter will never show a question mark again. Now that we have added 0 to 9 to the range, if you run the simulation again, you will see the counter working perfectly. Now let's try displaying a float value, a number with a decimal point. So go back to the code. I will comment out the integer code we just wrote and uncomment the second example line. This is designed for floats value. First, I need to define my variable. I will create a static float and initialize it to 0. Next, I want to increase this value by 0 0.1 every time the function is called. For floats, we use a slightly different function called Unicode smprintf floats. I also need to change the format specifier in the quote mark. If I just use a %f, it will show many decimals after 0, which might look a little bit messy. And since I only want to see one number after the dot, I will write %.1f. Finally, just like before, make sure you're targeting text area 2 buffer, and let's compile and run the simulation to see the decimal counter in action. Now you can see that my number increases every time the function is called. Before we move on to displaying strings, let's take a closer look at the Typography tab. If you need different font style for different parts of your app, you can create a new one by pressing the Add button at the top. Here, you can change the font family to any font installed on your computer. Next, you can choose the format, bitmap or vector. Bitmap pre-renders the text as image. This is the fastest method and the best for performance. Vector renders the text in real time. This is useful if you need to scale the text size dynamically, but it takes more processing power. Then we have the BPP. BPP stands for bits per pixel. A higher number, like 4 or 8, makes the edges more smooth, but it also uses more memory. It controls the anti-aliasing or smoothness of the text. So if you set this value to 1, the text is purely black and white with jagged edges. But if you, for example, put it on 4, the text has gray edges and it blends to the background and it will also look smoother. So I recommend it to put it on 4 and just use 1 BPP only if you are running out of memory, which is rarely happen in these microcontrollers. And we also have the compressed one, and if you check this, TouchGFX will compress the font data. Okay, now that we have covered the fonts, let's move to the text tabs right next to typography. This is essentially the database for every word used in your application. Every text resource here must have a unique text ID. TouchGFX usually auto-generate this, but it's a good practice to rename them to something meaningful. Also, you can do the grouping here. This is very useful for organizing your project and keeps everything tidy. You can create different groups, for example, one for buttons, the other one for the headers, and you can assign a specific text resource to these groups to keep things tidy. Reusing text is also a powerful feature here. You can have multiple text widgets on different screens, all pointing to the same text ID. And this is also useful for your project because, for example, if you have decided to change a word, for example, changing the stop to cancel, you only have to change it once right here in the list. So this text will be changed through all your application. So it saves you a lot of time compared to changing them one by one. Finally, let's see how to display a dynamic string on the screen. I'll drag one last text widget onto the canvas. Just like before, we need to add a wildcard. Since we are displaying words now, we need more memory space than we did for the numbers. So in the wildcard buffer settings, I will set the size to 20. This will give us enough room for short sentences. Now let's generate the code. Back in our C++ file, I will use the string function we saw in the documentation earlier. I will paste the example code and update the widget name to text area 3. And you also notice a new function here called resizeToCurrentText. So if the new string is longer than the previous one, this function automatically expands the width of the widget so that the text doesn't get cut off. It is very useful for dynamic content. Finally, as always, we call invalidate to redraw the screen. Now let's run the simulation again and see our text string update. Now let's test the wide text action option to see exactly how they handle text that is too large for the widget. To show you how this option works, first I will change my text string to something long, like TouchGFX is amazing. Next, and this is a little bit important, comment out the line for resizeToCurrentText. And why do I do this? Because if we leave this line, the widget will just grow to fit the text. By removing it, we force the widget to stay small, which allows us to see how the wide text action handles the overflow. Okay, now let's run the simulation with different settings. So on the first option, when it is set to none, the text simply ignores the borders. It gets cut off instantly at the edge of the box, often right in the middle of the word. So let's check the other option. This option tries to put the words into the next line. However, since my text box is only one line height, the second line has nowhere to go. The words, well, amazing is pushed down because the height is fixed. This shows if you want to use word wrap, you must ensure your text area is tall enough. I recommend trying this option yourself to see which one fits your specific design needs. Finally, let's look at the APIs. If you go back to the documentation page, scroll down to the bottom of the page, you will find a link to API reference. So what is an API? So think of the MPI as a menu of commands. It is a list of every single instruction you can give to the widget using the code instead of using the mouse in the designer. In this list, you can find commands to control almost everything. For example, you can set the color and set the alpha, set X and set Y to move the widget around the screen, and also the resizeToCurrentText, which we used earlier to adjust the width. So let's try one of these. I want to animate the text moving across the screen. I will go back to my handleThink function. This function runs 60 times a second, so it is perfect for animation. I will write a simple line of code to increase the X position of the widget by 1 pixel every tick. One important thing to notice: when moving a widget manually, you have to follow a specific pattern. So you have to invalidate the widget at first to tell the screen to redraw the old position in order to clean the text, then change the coordinates, and after that invalidate it again to tell the screen to redraw the new position. If you don't do this, you might see a blurry trail left behind, which we call it ghost. Let's run the simulation and watch the text move. And that covers everything you need to know about the text widget in TouchGFX. We've gone from a simple drag and drop to handling wildcards, fixing typography issues, and even using the APIs to animate text with C++. If you have any question or run into any specific error with your code, please drop a question in the comment section below. I will read all of them and try to help where I can. If this video was helpful to you, please hit that like button and consider subscribing to my channel for more embedded UI tutorials. Thanks for watching and happy coding!